this video, we are going to take a look at some issues with regard to front-end security. Now, let's look at a few possible scenarios in the context of an app that somebody is going to use. One of the key principles is with regard to how interactive is the site. Right? So you might have a static site, which is HTML only, and essentially is information. It does not collect any information about the user. Now, this is very simple from the point of view of the developer. Of course, it's arguable that maybe you can't really even call them a developer at that point. But whoever has created that website is not really collecting any user identifiable information. Now, on the other hand, you might have a simple form-based site. Maybe it might be something as simple as, you just collect people's email in order to send them information whenever there's an update on the site. Now, over here, whatever the user fills in is personally identifiable information, right? If you're collecting email, for example, that would be the information. If you ask them for the name, that's whatever the user fills in. Now, we are not even arguing about whether or not the person fills in correct data, right? The point is, when you put a form like that, there is a good chance that somebody does fill in correct data, which means that you are now responsible for whatever data has been collected through that form. And finally, of course, nowadays, pretty much most of the web consists of fairly dynamic websites with a significant amount of JavaScript, complex forms, and a large amount of data that is being collected from the user. Now, all this is with regard to direct user interaction. In addition to that, you also have several kinds of resources, right? So, for example, you might find that cookies are being set by various websites and are being used in order to track across sites. There is also the notion of other resources such as images or CSS files or JavaScript, all of which are being downloaded through just by opening up a web page, right? And potentially even a CDN, a content delivery network, could potentially keep track of how many people, for example, are downloading certain kinds of resources, right? Or they could even have a page over there which serves a certain kind of image, and that's embedded in certain locations, and automatically the content delivery network knows which sites are being accessed, right? So there is potential information that is being collected over here without even the user being aware of it, or without even really being able to control it in any way. The third scenario is outright malware, right? Where there is some kind of malicious JavaScript code or some other potentially even code that directly downloads and runs as an executable on your computer, right? And once that happens, a lot more can be problematic. You might have spyware installed on your machine. You could have keyloggers, which are keeping track of what you type. And at a sort of simpler within the browser level, you might find that there are data leaks between the different tabs that are being used in the browser. So what follows over here is essentially a non-exhaustive list of good practices or general principles that you can follow in order to reduce the chance of data leaks. Okay, so please keep that in mind. Everything over here in this lecture is ultimately non-exhaustive. In order to really understand all the different principles here, all that we are trying to do is give a flavor for the kinds of problems that you might have to keep in mind. But going into this in detail in terms of application security is probably at least one course by itself, and ultimately is best done through experience. You need to really understand these issues through practical experience and then see how you can deal with them as they come up. So let's take up some of the topics. One of them is with regard to cookies. We have already discussed cookies in regard to authentication, right? And we know that there is this concept of session cookies versus permanent cookies, right? And one of the sort of most benevolent uses of cookies is for logging in and using sites. Using a cookie, even if it's just a session cookie, allows the server to keep track of who is logged in, right? And once you log in and give the correct password, you will be, and it will set a kind of cookie which says, okay, now I understand, and as long as you can give me this cookie on every request that you make, I won't keep asking you for your password. Okay, so session cookies are good that way. Permanent cookies are a little more problematic potentially. They are the ones that come when you do things like remember me on this computer. They're problematic primarily because they are automatically activated by the browser. Once a permanent cookie has been set, the browser will just automatically send it to the server without checking with you each time. Now, this is primarily for convenience, but on the other hand, potentially might be a data leak. solution is usually fairly simple. You could turn off cookies in a lot of cases through most browsers today. And of course, the GDPR that we discussed earlier, the General Data Protection Regulations from the European Union, led to this site uses cookies banners that you see on pretty much every site nowadays. Right? So all that happens is the application developers have to inform users if they are setting cookies. And that's a good first step. It may not protect you by itself, but it at least makes the users aware. Now, another way of looking at cookies is that they could be either first party or third party, right? I mean, you don't really have second party because first party just takes care of the entire client and server relationship, right? And what we have is that first party essentially means if you are connecting to a given server, right, the server sets a cookie that relates only to its own domain. Okay, so that's good. I mean, you might actually find that useful for logging into the server, for example. But there may be cases where there, at least in the past, there used to be this concept of so-called third-party cookies, right? Where essentially what would happen is that for every website that you go and visit, you might also be asked for some kind of a third-party cookie corresponding to some other website that has nothing to do with the site that you are visiting. Usually, this used to be from advertisers because they would be trying to keep track of which sites you are visiting so that they can collect information that can enable them to give you targeted advertisements. Now, of course, they claim that's good for you. A lot of people disagree. They feel that that's too much information, right? And that's actually invasive of privacy. Now, most browsers today are actually starting to block third-party cookies, right? And or at least severely restrict the kind of third-party cookies that can be used. So this is already a good first step. In other words, most of things with regard to cookies can sort of be handled at the browser level. And the main thing is that you need to be aware of what is happening and how this information can be used. Now, another potential problem that happens in the context of usage of browsers is something called cross-site scripting. Right? Now, this can be explained through a simple example. I'm just using the text over here and not really showing a full application because it's reasonably simple to explain. Just imagine that you have a page that essentially contains a query field, right? Something where you can enter text and it does not validate that text in any way. Okay. Now, I'm just using the URL example.com/help. And what happens is that whenever you type something into that query field and enter it, it would perform a GET request to that URL with whatever you have typed in the message. And what it does is take that information and directly create a HTML page, which is finally displayed to the user, containing the text of that, whatever you typed in there. Now, the problem is because this was something that could just be a GET request, potentially a bad actor could then redirect you to another page where they show you a well-crafted link, one which says http example.com/help q equal to and whatever the script after that, right? So it has a script tag. The problem is if your server is just taking this without any form of validation, what will end up happening is that the data from that whatever was entered in the script tag will directly be output into the page. And what happens is that it could even have something which automatically loads and executes the script from a source that is not example.com, not the place that you thought you were visiting. Okay. There could be other variants of this where the malicious code, rather than coming through a URL, could be stored in the site database itself, perhaps through forum posts or blog comments, etc. Ultimately, what is happening is that the attacker just needs some way of injecting this code into the URLs. Now, one of the things, of course, is something that we have discussed quite well in earlier videos, which is that you need to validate data, right? You need to try and prevent such kinds of injections from happening. And to a large extent, it can actually be done. But on the other hand, on the client side, you could also do things that can prevent automatic cross-site script loading. And there are, in fact, cross-site scripting blocking techniques that can be used in order to at least understand that something like this might be happening, and even at the browser level, provide you with some degree of protection. Another type of browser level vulnerability is so-called CSRF, or cross-site request forgery. An example of this, once again, is something that can be explained using a couple of URLs. Let's say that you have logged into your bank account and you have an active session. And let's say that this bank is actually doing a fairly good job and provides you with an API, right? Which unfortunately most banks actually do not easily provide. Maybe they are trying to prevent these kind of problems, but on the other hand, having APIs also allows cleaner applications to be developed in other contexts. Anyway, be that as it may, if the bank has an API, and let's say that the API looks something like this, it essentially has a URL, bank.example.com/transfer, and within the request, it has source equal to ABC, target equal to XYZ, amount equal to something. It could be a GET request, it could be a POST request, right? It doesn't really have to be GET request alone. And in principle, what happens is that this works only after you have authenticated. So that sounds good. In other words, the API will only work if you have successfully authenticated. So it checks your cookies, authentication, and so on. So that's fine. From the bank side, they have done their homework. They're doing the right thing. The problem is within the same browser, let's say that you open another tab and you go to a page where you find a link. You don't read what the link URL is, and you click on it. And it turns out that that URL was actually something going to the same bank, bank.example.com/transfer. And now it had a URL which basically said, take the same source, that is your account. But now, instead of XYZ, which was where you wanted to transfer money, transfer it to some other target, and maybe some huge amount as well, right? As far as the bank is concerned, it cannot differentiate between whether you clicked on their website or you clicked on some other link that provided the correct information. Remember that HTTP is stateless, right? Every request has to sort of stand on its own. That is what is the problem over here. So because of that, the fact that you clicked on a URL in another tab created by the attacker versus you clicked on the URL on the bank's page cannot really be differentiated by the bank. Now, there is a way around this, and what is done is usually to introduce something called a CSRF token, a cross-site request forgery token. This is something which is created through the application. So in other words, only on the particular page that you are visiting the bank itself, the token will exist. And unless you provide that token along with the data, you cannot really use the bank's API. Okay. Now, CSRF is not as easy as I've made it out over here. One of the biggest problems, obviously, you can think about is the fact that the attacker also needs to create a URL that has your source information, the source account information, and so on. Right? So they need to have some information about you and create a URL specific to you. Having said that, that's definitely possible. It's not even very hard if they have some additional information about you. Okay. So CSRF is something that needs to be taken care of. As a developer, this is something you need to be aware of. So then you bring in CSRF tokens that ensure that your application access is being kept secure. Another topic in this regard, with regard to the browser, is something that you might have come across while implementing basic Flask applications. This is called cross-origin resource sharing. And effectively, what we are trying to do is we are trying to say which URLs are allowed to be originators of data. More importantly, you're also trying to say if there is a front-end website like www.example.com, which in turn needs to make a request to an API server, right, which could be api.example.com. It's a different server, right, because that makes sense. You do not want to run everything on the same machine. The query that goes to api.example.com will be ultimately originating from www.example.com, right? And effectively, what we are saying is that the API server, right, is allowing the www server to make requests on behalf of the user. Okay, so CORS is a way of restricting the chance that you are completely redirected to a different source for running something else. It allows the API server and the app developer to essentially say where you are allowed to make requests from, right? Now, as usual, the Mozilla Developer Network has useful information about these headers, right? The kind of information that can be used over here. And if you go to the Mozilla website, you will see that the access control allow origin has been described in detail over here. It basically says what kind of information you can put in over there and what it means, right? So different kinds of meanings over here for where you are allowed to have access to a given site from. Now, generalizing this idea of browser related restrictions is this notion of the content security policy, right? It's a more generic approach to applying policies. And once again, the MDN has quite a bit of useful information about it, right? So basically, it's an added layer of security. It helps to detect and mitigate various types of attacks, including cross-site scripting and data injection attacks, right? And ultimately, as you can see from the MDN website, what happens is you do need to configure your web server, right? So these are things that you need to be aware of as an application developer. It's not something that the end user does at their browser. You as the web developer need to put in this kind of information, right? And you can sort of see the kind of useful information that goes in there, right? You could potentially have policies which say things like the default source for all requests are only from self, right? In other words, a website administrator wants all the content to come from their site's own origin, not even subdomains, okay? But if you want to have the origin as well as subdomains, you could put in something like this, right? Or you could say that images are allowed from anywhere. Other kinds of media are only from some other URLs. Scripts are only from a particular URL and so on. Okay. So there's a lot more to this that you can do. In fact, this website, this web page also goes into details on how you can test it. You can have reporting. As a web server administrator, you get a lot of control over applying certain kinds of security policies to your website. Okay. And it's good practice to do this because it reduces the chance that something will go wrong and that your website inadvertently ends up causing problems for the end users. There is also a notion of something called a secure context, right? And a secure context is essentially brought in with the idea that within a browser, there might be certain kinds of things that should be allowed only within secure contexts. An example of this is the access to the camera and the microphone that are present inside a laptop or a tablet, right? And why do we call this a secure context? Because we do not want just any browser or any tab to be able to get access to this. We want to ensure that the user is aware of what is happening in the secure context. We want certain minimum requirements to be satisfied for the secure context so that you can allow access to certain kinds of resources. So the MDN has information about the secure context. It basically says it's either a window or a worker for which certain minimum standards of authentication and confidentiality are met, right? And of course, it also goes into details on why should some features be restricted and when is a context considered secure, right? And the actual details of how secure contexts are defined is once again part of the W3C standards document, right? So there is a standard document that you can find over here, which of course is in a lot of legal sounding terminology, and it's clearly a formal document because it has like very carefully constructed wording, but it also has a lot of very useful diagrams that give you a better picture for what is and what does and does not constitute a secure environment or a secure context, right? One of the primary things that is required for this security is the fact that instead of HTTP, you need to be using HTTPS. The idea is that as long as you're using HTTPS, you at least have a guaranteed secure connection between the end user and the server from which they're getting the web page, right? And that is the most basic requirement that you have, right? Now, of course, they also say there are multiple other things that can happen. So for example, you might have nested pages. This is typically done using something called an iframe, right? Or an embedded frame. And if you have such embedded frames, it's possible that you have an outer secure context, but the inner thing is actually not HTTP, in which case the inner context is not considered secure. And sometimes in browsers, you might have come across this sort of warning saying that there is mixed content, right? There are some parts of this page that are loaded from insecure servers, right? All of these are warnings. The primary reason why HTTPS is considered such a big deal is because HTTPS at least gives you a reasonable guarantee that you got the data actually from the source that you try to download from. Whereas with HTTP, it could potentially have been replaced at any point, or even new information could have been injected at some point as it was coming through the wire. And you do not really have a way of ensuring that that could not have happened. So secure contexts are used primarily to sort of restrict permissions, or more importantly, to enable certain kinds of permissions. That is, some kinds of activities or some kind of access patterns can be used in specific contexts. Another thing that can be used for browsers is something called a sandbox, right? And most browsers, in fact, have some kind of sandbox type of behavior. The primary idea of a sandbox is that it's the term itself comes from children's play areas, right? You have a sandbox that is put in a play area for children, and the idea is that as long as the child is playing around in that sandbox, they are unlikely to harm themselves. They are not really going to go and cut themselves on some sharp-edged objects, because you just have to make sure that that sandboxed area is kept free of any potentially harmful objects. In the same way, in a browser, what you do is that you say that as long as you are within the sandbox, you are not, it's not possible for you to make any harmful changes. In other words, you cannot go and delete any files. You will probably not even have access to read certain kinds of files, such as operating system files or other things that could potentially leak information, right? You may have very restricted network access, or maybe no network access at all. You probably don't have access to camera, microphone, etc., unless it's been explicitly permitted for this particular sandbox, right? So many access patterns are restricted. Once again, there are websites that go into quite a bit of detail on this, right? Chromium, which is the open source code base on which the Google Chrome browser is based, has a fair amount of information about sandboxes. This information about sandboxes in the Chromium website is primarily meant for developers, right? But on the other hand, it also does have useful information in terms of why sandboxing is required, right? So it sort of talks about the fact that security is one of the most important goals, and the key to security is understanding. You need to sort of understand what are the potential problems. Only then you can sort of take steps to prevent them from happening. There are a number of design principles, right, which some of which we have discussed before, especially things like the principle of least privilege and so on, which sort of implicitly prevent the sandboxed environment from accessing anything more than it needs to have access to. So, as I said at the start of this video, this is not at all close to an exhaustive list of potential problem areas or even topics that you need to be aware of. But the thing is, as a web developer, you need to understand your platform. And the browser is the most important part of the front end, because today, pretty much everything, any new kind of application that we are trying to develop is going to make fairly heavy use of the capabilities of the browser, right? Especially with front ends like the JavaScript based front ends, Vue, React, and so on. You are trying to bring more interactivity, but the potential flip side over there is the fact that those also have access to information and parts of the system that you need to be careful about. Ultimately, the security of the system comes through a combination of browser and server techniques. You cannot rely completely on the server alone and leave the browser to do whatever it wants. At the same time, you cannot think that everything is being blocked by the browser, because it's also possible to access the server without even using a browser at all. And as we have seen, one of the most important things over here is that user awareness or user information, right? The fact that the user education, right, is essential in these contexts. You need to be able to tell the users what is and is not essential in terms of the information that you are collecting, and also about how you store the information, how you use it, who you share it with, and so on.